Before revealing the shocking winner that automotive experts consider the most dependable vehicle available today, and trust this choice will surprise even the most experienced car buyers. Let's start with number 5. But here's what most people don't realize about reliability in 2025. The real value isn't just in avoiding breakdowns. Stay until the end, because the number 1 spot represents something that changes everything about long-term vehicle ownership. At number 5, the 2025 Honda Pilot ranks as one of the most dependable mid-size, 3-row SUVs available today. The engineering behind this vehicle represents decades of refinement in Honda's approach to family transportation. The V6 engine paired with a 10-speed automatic transmission creates a powertrain setup that has demonstrated consistent long-term durability across multiple generations of testing and real-world usage. This powertrain combination didn't happen by accident. Honda engineers spent over 4 years developing the transmission mapping to work specifically with the V6 torque characteristics. The result eliminates the harsh shifting and premature where that plagued earlier automatic transmissions. Internal components use hardened steel construction in high-stress areas, while fluid circulation systems maintain optimal operating temperatures even during extended highway driving or heavy load conditions. The chassis engineering focuses on balance and stability over extended driving periods, systematically reducing stress on suspension components and critical wear points throughout the vehicle structure. Honda's approach involves distributing loads evenly across the frame, preventing concentration of stress that leads to premature component failure. Suspension mounting points use reinforced brackets that have proven effective across hundreds of thousands of miles in testing protocols. Interior construction prioritizes simplicity and endurance over flashy technology that often fails after warranty periods expire. Physical controls remain functional even after years of daily use, because mechanical switches and knobs don't suffer from the electronic failures that plague touchscreen-only interfaces. Radio controls and essential vehicle functions operate through direct mechanical linkages that maintain consistent operation regardless of electronic system status. The design deliberately avoids excessive electronics or fragile materials that contribute to higher maintenance costs over time. Dashboard materials resist cracking and fading even under extreme temperature variations. Seat fabrics and trim pieces use industrial-grade materials that maintain appearance and functionality after years of family use and daily wear patterns. But here's what Honda doesn't advertise about Pilot ownership patterns. Data from previous models shows an exceptionally high rate of long-term owner retention, with most families keeping their Pilots well beyond typical trade-in cycles. Here's what makes number 4 controversial. Despite being positioned as a luxury brand, the next vehicle actually costs less to maintain long-term than many non-luxury competitors, and the reason involves a single engineering decision that most buyers never consider. Number 4 goes to the 2025 Lexus NX, a compact luxury SUV recognized for its consistent mechanical reliability in the luxury segment. The platform foundation uses tested configurations that avoid sudden design shifts or improving components that often plague first-year luxury models from other manufacturers. Lexus engineers deliberately chose evolutionary rather than revolutionary changes for the NX platform. This conservative approach means every major component has been validated through extensive testing cycles before reaching production. The transmission, suspension, and electrical systems build upon proven architectures rather than introducing untested technology that could compromise long-term dependability. Power delivery systems operate within stable performance ranges that prioritize longevity over peak output numbers. The naturally aspirated engine option avoids the complexity and potential failure points associated with turbocharging systems. The hybrid variant continues to deliver efficient fuel mileage without introducing the additional complexity that often reduces reliability in competing hybrid systems. Toyota's hybrid technology, which powers the Lexus hybrid system, has accumulated over 2 decades of real-world validation. The electric motors use permanent magnet construction that eliminates brush replacement requirements. Battery management systems include multiple redundancies that prevent catastrophic failures, while cooling systems maintain optimal operating temperatures across all climate conditions. Interior material selection focuses on durability that maintains luxury appearance over extended ownership periods. Leather surfaces resist cracking and wear patterns that become obvious in other luxury vehicles after just a few years. Synthetic materials used in high-touch areas actually outperform genuine materials in terms of long-term appearance retention, while maintaining the tactile quality expected in luxury applications. Physical controls remain in place for essential functions, reducing dependency on touchscreen-only access that becomes problematic when screens fail or respond slowly. Audio system management and vehicle settings can be adjusted through traditional knobs and buttons that continue functioning regardless of infotainment system status. What's surprising about number 3? This next vehicle actually costs less than the Lexus, but offers something that luxury brands struggle to match, and it involves a fundamental approach to engineering that most car buyers never fully understand. In third place, the 2025 Toyota Highlander remains one of the most structurally consistent mid-size SUVs available in today's market. The engineering behind this vehicle represents Toyota's systematic approach to eliminating common failure points that plague three-row SUVs from other manufacturers. The V6 powertrain and transmission configuration draws from a documented history of high-mileage performance that spans multiple vehicle platforms. This engine family has accumulated millions of miles in various Toyota and Lexus applications, providing engineers with extensive data about wear patterns, optimal maintenance intervals, and potential weak points that have been systematically addressed through design improvements. Suspension system engineering focuses on even load distribution across all mounting points, which significantly reduces stress on critical joints and linkages that typically require expensive repairs in other three-row SUVs. The McPherson strut front suspension and multi-link rear configuration have been refined through multiple generations to eliminate premature wear patterns while maintaining ride comfort under various load conditions. Interior layouts follow established Toyota design standards that prioritize functional durability over experimental layouts that often prove problematic after extended use. Dashboard construction uses materials and assembly techniques proven across millions of vehicles, while seat mechanisms employ mechanical adjustments that remain precise even after years of daily use. The approach deliberately maintains physical switches and standard interfaces for essential vehicle functions, reducing dependency on digital-only controls that become expensive repair items when they malfunction. Audio management and lighting controls operate through direct mechanical or simple electrical connections that rarely require professional service. Real-world ownership data demonstrates that Highlander models average fewer unscheduled service visits compared to competitors in the mid-size three-row segment. Maintenance requirements stay predictable, with most owners reporting only routine service needs like oil changes, filter replacements, and brake maintenance throughout typical ownership periods. The next vehicle costs even less than this Toyota, but has achieved something remarkable. It's managed to solve a problem that has plagued compact SUVs for decades, and most buyers don't realize this solution exists. Second place belongs to the 2025 Toyota RAV4, a compact SUV that maintains exceptionally strong mechanical performance records across multiple ownership cycles and various driving conditions. The engineering success of this vehicle stems from Toyota's systematic approach to eliminating the reliability issues that historically affected compact SUV designs. Powertrain components undergo calibration specifically designed for steady performance delivery, with manufacturing tolerances that significantly reduce premature or compared to competitors that prioritize peak performance over longevity. The four-cylinder engine family uses internal components designed for extended service intervals while maintaining consistent power output across hundreds of thousands of miles. Structural alignment engineering ensures the vehicle maintains consistent geometry under load conditions that would stress other compact SUVs. Frame construction distributes forces evenly throughout the chassis, contributing to extended frame longevity and maintaining ride uniformity even after years of daily driving across various road conditions. Material selection throughout the interior prioritizes endurance and surface stability over trendy appearances that deteriorate quickly. Fabric selections resist staining and wear patterns while maintaining their original appearance longer than materials used in competing vehicles. Hard surface materials resist scratching and maintain their finish quality throughout typical ownership periods. Mechanical controls are deliberately retained for key vehicle operations to reduce the risk of touchscreen failure affecting essential functions. Physical knobs for frequently used features continue operating even if the infotainment system experiences problems, ensuring drivers maintain access to critical vehicle functions. Hybrid variants benefit from Toyota's long-standing battery and electric motor configurations that demonstrate consistently low fault rates and extended component expectancy. The hybrid system integration avoids the complexity that reduces reliability in competing hybrid systems, while battery management prevents the degradation patterns that affect other manufacturers' hybrid offerings. Now for number 1. And this will surprise everyone who thinks they understand what makes a vehicle truly dependable. The most reliable SUV of 2025 isn't from Toyota, isn't the most expensive, and offers something that no other manufacturer has managed to achieve consistently across all their vehicle platforms. At number 1, the 2025 Subaru Forester stands at the top of this reliability ranking based on comprehensive data from long-term usage studies across multiple model years and various driving conditions. The engineering excellence of this vehicle represents Subaru's unique approach to solving the fundamental challenges that affect SUV reliability. The structural foundation relies on Subaru's symmetrical all-wheel drive system paired with a naturally aspirated boxer engine configuration. This combination creates inherent balance and even-wear distribution that eliminates the stress points responsible for premature component failure in other SUV designs. The boxer engine's horizontal layout lowers the center of gravity while distributing weight evenly across the chassis. Power delivery characteristics remain stable across an exceptionally wide range of operating conditions, reducing strain on transmission components that typically experience accelerated wear in other all-wheel drive systems. The continuously variable transmission uses a chain drive design that eliminates the belt-related failures affecting CVT systems from other manufacturers. Subaru's all-wheel drive system operates full-time rather than switching between front-wheel and all-wheel drive like most competitors. This consistent operation eliminates the mechanical complexity and failure points associated with systems that must engage and disengage all-wheel drive based on traction conditions. All four wheels receive power continuously, preventing the sudden load changes that stress drivetrain components. The undercarriage layout ensures minimal impact to joints and suspension arms during regular operation across various terrain types. Suspension mounting points use Subaru's ring-shaped reinforcement frame structure that distributes loads more evenly than conventional mounting systems, significantly extending component life expectancy. Interior materials demonstrate exceptional resistance to surface breakdown even under intensive daily use conditions. Seat fabrics and trim materials maintain their appearance and functionality longer than materials used in competing vehicles, while mechanical controls retain their precise operation feel throughout extended ownership periods. Analog-style controls are maintained for essential vehicle functions to minimize electronic system failure risks that could affect basic vehicle operation. Lighting and other critical systems operate through direct connections that rarely require professional service or expensive electronic component replacement.